Hello, IB, and welcome to the last section of your first chapter of standard level. Congratulations, you've made it through your first chapter. We're going to be discussing the second half of application questions, which has to do with optimization. When you optimize, you're finding the minimum or maximum value of a function. So we're really looking for the vertex, and you guys already know how to do that. So you've already got some experience looking for your vertex. However, when we say minimum or maximum, it's not just the vertex, it's actually the y value associated with that vertex. It is the lowest value that your quadratic drops to or the highest value that your quadratic comes up to. So when you leave your answers for optimization, and you're finding a max or a min of a function, you're really talking about the y value. So just make sure you leave that specifically in your answers. And understanding why that is the case, right? So your maximum value is the highest value your quadratic will reach. So in this case, we're actually looking for, this is a very straightforward question where they're asking you to find the maximum or minimum. And already there are a few things I'm going to notice. I have an a value of 2, so my a value is greater than 0, which means my quadratic opens upward, and I will have a minimum. So I already know, and I already have an idea of what I'm going to find when I work through this question. So I'm going to start, I need to find my minimum value, so I'm going to start by trying to find my vertex, and that begins with your axis of symmetry, using x equals negative b divided by 2a. So for this particular question, I will have negative 1 divided by 2 times 2. So my x value that corresponds to my vertex is negative 1/4. In order to find my y value, your y value will be negative 1/4 squared times 2. So I'm just substituting it in to my function. Remember, we're going right back here to substitute in. Let's see, plus negative 1/4. And this would be a great time to pause and try it yourself. Make sure you guys come up with the same y value that I do. But if you wind up simplifying that by hand or with your calculator, you come down to negative 1 1/8. Again, this is something we should be able to do without a calculator. So writing my sentence, this function has a minimum value of negative 1 1/8 when x is negative 1/4. And that's pretty much a really straightforward question, just asking you to do that couple steps, but really just looking for your vertex. And we've done this 1,000 times. The more challenging question is when you have to put it into a real-life scenario. So when you're looking at this number 6, and it's from your section in the textbook, 500 meters of fencing are available to make 4 rectangular pens of identical shape. Find the dimensions that will maximize the area of each pen if this is the plan. So I'm going to do A with you, and I'll leave B for you guys to try. Little question mark there. That's for you guys to try before you guys come to class. See if you can do the same thing that we're about to do with this part A. If I'm going to maximize the area of each pen, I'm really going to find the maximum area of all 4 put together, right? So if I have 500 meters of fencing, we're being told something about the perimeter, all right? And we're being told to maximize the area, so we're also thinking about our area. I have no labels on this diagram at the moment, so I'm going to go ahead and call the small sides of each rectangle x and the larger sides y, or the longer sides y. So I know that my perimeter means that I have, if I'm making these 4 pens, and I'm using 500 meters of fencing to make the 4 pens, I need to use 6 x's, and I have 6 y's as well to make that 500. So I'm going to rewrite that. 500 is equal to 6x plus 6y. That's the fencing that's used for all 6 sides, 6 little segments that make this diagram. And then my area would then be, since this side is 2 x's, it would be 2x, and the top length is 2 y's by 2y. All right? So these are the things that I already know, just from reading the question and looking at the diagram. I can set up 2 different equations because you're told something about the area, and you're told fencing, which we know goes around the outside, and that tells me that I'm using perimeter as well. So now I really want to use this area equation because I really do want to focus on area since it's asking me to maximize the area of each pen. However, if you notice, so step 1, I'm going to use my area. If you notice, though, I have 2x by 2y. I have 2 unknowns. And I can't really do a whole lot with an equation when I have 2 unknowns. So one thing that we were told was this perimeter. because we're going to isolate either the x or the y so that we can substitute it in to this area equation. All right, so what I'm going to wind up doing is a little side work. I'm first going to have to take my 500 equal to 6x plus 6y, and I'll have to isolate either my x or my y. It really doesn't matter which one. But if I do 500 minus 6x equals 6y, then y is equal to 500 minus 6x divided by 6. At this point, because I've now isolated my y, I can substitute it in and replace so that I'm only dealing with x's. So let's come back over here to my step 1, and I have 2x brackets 2, and then that's going to be multiplied by 500 minus 6x over 6. Again, always try to reduce, simplify as much as you can. So I'm really working with, let's say I've got 2x. This is really going to be 500 minus 6x over 3. All right? And I'm going to pause here just for a moment because I could continue to expand this. However, remember, if I do expand this, I should wind up with a negative quadratic. If you were looking at it in standard form, you'd see your a value is negative, and I can tell that already because here's the 2x and here's the negative 6x, so that'll make a negative 12x squared. But what I really want to be looking for is the maximum. So again, we're thinking about your vertex, and I know that my vertex is directly in the middle of my two roots, or x-intercepts. And if you guys look at how this quadratic is already set up, it's actually set up in factored form. I have 2x multiplied by 500 minus 6x over 3. So if I set this equal to 0 at the moment, I could go ahead and find my p and q value, my two roots, and I could also find my vertex that way. So we'll try this one a little differently than we've done some of the others in class before. So for this one, we'll wind up just saying if I'm going to set it equal to 0, that means that 2x will equal 0, which means x is 0, or 500 minus 6x divided by 3 is equal to 0, which means 500 minus 6x equals 0, which means 500 equals 6x, and x will be 500 divided by 6. So if you're looking at both of these, we can identify this as your P and your Q. And if I want to find my vertex, it would be the average of those two. So I can take P plus Q and divide by 2. And in this case, since my P is 0, you're really just going to take the 500 divided by 6 and divide that by 2. So if I divide this by 2, though, all right, that's not a proper way. We want to rewrite that. It's really going to be 500 divided by 12, okay? And that winds up being 41 2/3. So I've already found my x value, which was the shorter side of my rectangle, to be 41 2/3, right? So if I still want to find my y value, since it asks for the dimensions, so I do want to find both x and y, we'll go back up and see where we can actually substitute back in to find our y. So if we go back through our work, notice up here where we had our perimeter, we had 500 equals 6x plus 6y. So there's a relationship between our x and our y, and we already know our x, so that would probably be easiest to substitute back into to figure out what our y is. Also, notice over here, we've already isolated our y from that perimeter equation. So you're really just substituting in 41 2/3 into this x right here. So 500 minus 6 times 41 2/3 and divide by 6. Go ahead and try it. Let's see what we wind up getting. So for this example, the x and the y actually come out to be the same to yield the max area. And for rectangles, your max area really does happen when you have a square. So we have 41 2/3 by 41 2/3. Let's make sure we answer the question. Find the dimensions that will maximize the area. So we found an equation for the area. We knew that if we found the maximum value of that quadratic equation, we would have the max value for our area, which then we would use the dimensions that created that. So let's go ahead and look back. The dimensions that yield our max area of each pen are 41 2/3 meters by 41 2/3. So your challenge is to try to set up an equation that you can use for the setup in B. So just using those 4 pens a little differently. Does that change the area then for the max that that pen can actually hold? All right. Good luck. Have a good night, and we'll see you guys next time.